We hear about new AI models coming out all the time, capable of creating art, writing poetry, or powering our favorite apps. But have you ever stopped to think about how these AI brains are actually built?
You'd probably imagine teams of brilliant engineers carefully designing every little piece, and that's often true. But what if we could automate that process? What if we could create a system that designs thousands of different AI brains, almost like an evolutionary process to see what works best?
As sort of Cambrian explosion for AI architectures?
Exactly, and that is precisely what a new paper we're looking at today is all about.
Welcome to Daily Papers.
Today's paper is called LEMUR2, Unlocking Neural Network Diversity for AI. It comes from a large team of researchers at the University of Würzburg in Germany.
Okay, so let's start with the problem they're trying to solve. Why do we need to unlock neural network diversity? Don't we have good AI models already?
We do, but designing them is incredibly complex and time-consuming. It's a bit like building a custom race car by hand. You need a lot of expertise, and you tend to stick with designs you know. The result is that a lot of research ends up focused on a very narrow range of AI architectures.
So everyone is working on slight variations of the same few car models, so to speak.
That's a great way to put it. And there's another problem. Most academic benchmarks tell you how accurate an AI model is, but they don't tell you how fast it will run on your actual phone or inside a VR headset. There's a big gap between theory and practical performance.
And that's where Lemur 2 comes in. What exactly is it?
Lemur 2 isn't a single AI model. It's a massive framework and dataset. Think of it as a giant zoo for AI models. It contains over 14,000 distinct AI architectures and more than 750,000 records of how they performed on different tasks.
The key word, as you pointed out, is diversity. They didn't just build one type of model. They tried to build as many different types as possible.
14,000! How on earth did they create so many different designs? This can't have been done by hand. Absolutely not. And this is the most exciting part of the paper. They used a whole toolkit of automated AI-driven methods to generate new models. It's like they set up an automated AI factory.
An AI factory? Tell me more. What kind of machines are running in this factory?
Well, one of their main tools is a genetic algorithm. It's literally survival of the fittest for AI. They start with a population of AI models, test them, and the best performing ones get to reproduce. Their code is mixed together and slightly mutated to create a new generation of AIs, which are then tested again. Over many generations, the models evolve to become better and better at their task.
So they're breeding better AIs. That's amazing. What else?
They also used a technique based on large language models, or LLMs, the same kind of tech that powers things like ChatGPT. In one approach, they would give an LLM a few examples of high-performing models and just ask it to invent a new one.
They're just asking an AI to design another AI?
Pretty much. And in another, even cleverer method, they used reinforcement learning. They would take the code for an AI model, hide certain parts of it, and then challenge an LLM to fill in the blanks. If the LLM generated a working, efficient model, it got a reward. It's like teaching an AI student how to build other AIs by giving it grades.
That is fascinating. It sounds like they're really pushing the boundaries of AI creating AI.
They are. They even have a system that's like an AI scavenger hunt. It's called NN-RAG, and it automatically scans public code repositories to find useful pre-built components, like Lego blocks of AI code. It then collects these into a library of over 900 reusable parts that can be snapped together to build new models.
It's a completely different way of thinking about AI design. Instead of one perfect handcrafted blueprint, it's about massive automated exploration and reuse.
And they don't stop at just creating the models. They took this huge zoo of AIs and put them through their paces in the real world. This is really what makes Lemur 2 stand out.
You mentioned testing on phones and VR headsets earlier. How did they do that?
They built two automated systems. One is called NIT Lite, which takes a model, converts it, and runs it on an Android device to measure its actual speed and efficiency. The other is NNVR, which does the same thing but inside a virtual reality environment built with Unity game engine.
Why is that so important?
Because in VR, performance is critical. If it takes the AI too long to process a frame, the whole experience becomes laggy and can make the user sick. You have a very tight budget, maybe just 11 milliseconds per frame. So a model that's 99% accurate but takes 100 milliseconds to run is useless in that context. LEMUR 2 connects the architectural design to this real-world performance.
So after running this huge experiment, creating thousands of AIs and testing them everywhere, what did they find? Did the AI factory produce anything good?
It absolutely did. They found that their AI-generated models were competitive with, and sometimes even better than standard models designed by humans. The genetic algorithm especially was particularly good, consistently producing strong, reliable architectures.
And what about the method where they just asked the LLM to design a new model?
That one was more of a high-risk, high-reward strategy. The LLM had a higher failure rate, but sometimes it would produce a uniquely brilliant design that other methods missed. It was less consistent, but more creative.
So there's a trade-off between the different generative methods.
Exactly. And they found some other fascinating little details. For example, when asking the LLM to create a new model, giving it 3 examples worked better than giving it 6. With too many examples, the LLM got confused and its failure rate skyrocketed.
It's like giving a student too much information at once. So what's the big takeaway here? Why does a project like LEMUR 2 matter for the future of AI?
It represents a major shift from manual, intuitive-driven AI design to a more automated, data-driven science. By creating this massive, diverse collection of models and testing them on real hardware, they've built an incredible resource for researchers.
So other scientists can now use this AI zoo to discover new design principles?
Precisely. They can analyze these thousands of models to figure out what architectural features lead to both high accuracy and high efficiency on a phone. It's about building a foundational dataset that can help us automate the development of the next generation of AI. AI that's not just smart in a lab, but fast and useful in our everyday lives.
So the future of AI design might involve less manual tinkering and a lot more automated evolution, creation, and discovery.
That seems to be the direction we're headed. LEMUR 2 provides a powerful roadmap for that future.